In this video, we're going to review everything that we've looked at so far with our ellipse. So when we started studying our ellipse, we looked at how to graph the ellipse from an equation given to us in standard form. So our standard form basically has two different versions depending on whether my ellipse is elongated horizontally, where my major axis would be horizontal, or vertically, where my major axis would go vertical up and down. And as we're writing the equation, we focus in on the center and then the distance from our center to the endpoints of the major axis and the endpoints of the minor axis. So in each of these equations, my center would be that ordered pair HK. And then our values for A and B come from our major axis and our minor axis. The distance from my center to the endpoint or of the major axis, or either of our two vertices, would be the value for A. And then the value for B is the distance from our center to either co-vertex. So when we have an ellipse elongated horizontally, then our major axis would be horizontal. So then my distance from my center to the endpoint would be a horizontal distance of A, and then my minor axis would be a vertical distance of B. Here, my minor axis would actually have a horizontal distance of X, and my A value would be a vertical distance. So when we want to look at our equation, the key thing to remember is that the value for A is always the bigger denominator. So as we're going to solve them, we're going to be able to figure out whether or not my bigger value is attached to the X coordinate and elongated vertically, or attached to our Y coordinate and elongated horizontally. So as we're going through, we're going to also bring into the picture now how we can graph the ellipse from the center, from the standard form, identifying the center, our co-vertices, our foci, and we're also going to bring in and review how to find eccentricity for ellipse as well. So whenever I'm trying to draw a graph, the first thing I'm going to find is my center coordinate, my values for h and k. So in this case, my center would be -2, +2, because it's supposed to be x minus h. So to make this guy positive, I needed a double negative. So my center here is going to be at -2, +2, and I'm going to go ahead and just plot that point for my center on my coordinate plane. And now to get the ellipse itself, I need to be able to draw the major axis and the minor axis so that I can get how rounded or not so rounded this shape is. So the next thing I'm going to find are my vertices. And I forgot to put those in my list here, so we're going to find those next. So to find my vertices, what I'm going to do is find my value for A, because each vertex is A units away from my center. And again, A squared is always the larger denominator. So in this case, A squared would be 25. And if I take the square root of that, then A would be 5. So my vertices are 5 units away from my center point. So I can do two things. I can either find my vertices by going to my graph and counting 5 units away. Since it's a horizontal distance, it's attached to the x, I'm going to count 5 units to the right and 5 units to the left. And those would be my 2 vertex points, or my vertices. And obviously, I just counted them on my graph, moving left and right 5 units from my center. I can now just grab those coordinates using my coordinate plane, or if they were further apart or I didn't necessarily have the graph paper, all I have to do is adjust the coordinate of my center that would change. And if I'm moving left or right, that would change the x coordinate of my center. And all I'm really doing is adding and subtracting 5 to that x coordinate of my center, but the height or the y coordinate of that point stayed the same. And if I do this math, you can see I end up with the same 2 points. If I add 5, that would move me right 5 spaces, and I would land at 3, 2. And if I subtract 5, that would move me left 5 spaces, and I would land at -7, 2. And those are the exact 2 points I found by counting my graph. So our vertices are always at the end of our major axis, and then our co-vertices are at the endpoints of our minor axis. And our co-vertices are always b units away. And so b squared is always the smaller denominator. So in this case, b squared would be 4. And if I take the square root of that, b would be 2. And I can see that that b squared value was attached to y. So that means that my b value is going to move up and down just like my y coordinates do. So my co-vertices are going to be 2 units up and 2 units down from my center. And again, I could just go to my graph and count them and grab my coordinates that way. Or as I shifted, I changed the y coordinate of those points, but not the x coordinate of my center there. So my co-vertices, I can find them by just keeping my x coordinate of my center the same, and then taking the y coordinate of my center and adding and subtracting that b value. And you can see if I do that math, I'm going to end up with the same 2 points. I would end up at negative 2, 4 if I add the 2, and negative 2, 0 if I subtract those 2. If I wanted to, now I could go ahead and draw my graph. I kind of think of them as little rainbows. I would draw like an arch through those guys and then do the same thing upside down. Try to make it as ovally as you can there. So that would be my graph for my ellipse. Now, truly, the ellipse is generated by these 2 points called our focus. And the 2 foci are our fixed points that are really determining the outer shape of my ellipse. So we're going to find those foci as well. And our foci are always what we call C units away from our center, and they lie on our major axis. So we're going to use our formula to find our value for C. And our formula is C squared equals A squared minus B squared. And the good news is we already have A squared and B squared because those are my 2 denominators. And so I always take the bigger denominator minus the smaller denominator. So in this case, 25 minus 4, and I'm going to find out C squared is 21. So if I want to find my value for C, I would take the square root of 21. And so my foci are radical 21 units away from my center. Now, if I want to get a better feel for how far that is, I can use my calculator and find out that that's about 4.6. So my foci are about 4.6 units off of my center, again, moving it the same way as my major axis. It's because they land on my major axis. So they're affecting the x-coordinate of my center. So to find my foci, I'm just going to take the x-coordinate of my center and add and subtract my C value. So my foci are going to go 4.6 units to the right. I'm just going to eyeball this guy, and then 4.6 units to the left. And again, I can graph them and grab them that way. Or again, I'm moving left, right, so I'm changing the x-coordinate, keeping my height or my y value the same. So my foci would be at about 2.6, comma 2. And then over here at about negative 6.6, 2. So those are our key points that we have for our graph. We have our center, our vertices, the endpoints of our major axis, co-vertices, the endpoints of our minor axis, and then our foci, those 2 fixed points that are actually generating the ellipse. The other thing we can talk about in terms of our ellipse is its eccentricity, and that's a value between 0 and 1 that's going to tell me how rounded my ellipse is. And so when we're looking at it, the closer that value gets to 1, the more and more elongated our ellipse is going to be. And all we do to find our eccentricity is we use the formula that is the ratio of our C value divided by our A value. And we already found our C value to be radical 21, and we already found our A value to be 5. So my eccentricity would be radical 21 divided by 5. And if I want to see, well, how close is that to 1, I could use my calculator and find out that this is about 0.92. So this is a pretty elongated ellipse, and we can see that in our diagram. So when we're looking at these formulas, we can obviously, when they're given to us in standard form, get all of the key characteristics that we need straight from the formula, and we're ready to go ahead and draw our graph and get our key points. The other thing we looked at was taking an equation from general form and rewriting it in that standard form, so then we would be able to get those key characteristics. And so we're going to kind of merge the 2 things that we looked at in terms of graphing and general form together and do one more example. So notice here it's not going to be as easy for me to go and draw my graph. And once again, I forgot to put my vertices in my list. Those are some key points that we need. So notice that it's not going to be easy for me to identify my center because I don't have that fraction set up and it doesn't say equals 1 like we want it to do. So when we're given an equation in general form, we're going to want to complete the square and rewrite our equation so that it matches up with that standard form so we can get those key characteristics. So I think about it as 5 steps. The first step we're going to do is we're going to want to make sure that our equation starts out where my x terms are together, my y terms are together, and my number is all by itself on the right-hand side of the equal sign. So my first step is always going to be to reorganize my equation to fit that format. So I'm going to rewrite this guy by putting the 25x squared and the 100x together side by side. And then I'm going to put my y squared and my y term together. So the 4y squared and the 16y together. And then I want that number on the other side. So I'm going to move that positive 16 over to the other side. I'm going to apply my property of equality and subtract 16 from both sides to make that negative 16. So that's step 1. Now, step 2, I want to get ready to complete the square. And when I complete the square, I don't want a value in front of x squared or y squared. So my next step is going to be to factor out the coefficients of x squared from the x terms, and then the coefficient of y squared from my y terms. So what that means is that in this first group, I'm going to factor out that 25. And then in parentheses, write what's left behind after I divide that away. So I'd be left with x squared plus 4x. I'm going to leave space for me to complete the square. And then I'm going to repeat and do the same thing for my y. So I'm going to factor out the value in front of my y squared term. So I'm going to factor out that plus 4. And then in parentheses, I'm going to write what happens when I divide by 4. So here I would get y squared plus 4y. And I'm going to leave space again to complete my square. And then I have my negative 16, and I'm going to put my things to balance my equation. So that's my step 2. Now step 3 is going to be to actually complete the square. So in this group, I'm going to find my value for b, which would be 4. I'm going to cut it in half, which is 2, and then I'm going to square it, which is 4. And I'm going to add 4. And then I'm going to complete the square over here. So same thing, my b value was once again 4. I'm going to cut it in half and square it, and so obviously that's again 4. And then the other thing I want to make sure I do is balance my equation, because whatever I add to the left side of my equal sign, I have to make sure I do the same to the right-hand side. Now just be careful, we're not adding 4 and 4, because we don't just have one group of those parentheses, we actually have different amounts. I have 25 groups of this x squared, and I have 4 groups of this y stuff. So when I'm balancing my equation, I have to remember to take the number in front and multiply it by the number I'm adding in. So I'm really adding in this group 100 and in this group 16. So now I've completed the square and balanced my equation. So I'm going to go ahead now and factor. The 25 is just going to hang out front as I factor, and this would factor as that quantity of x plus 2 squared. The 4 is going to hang out in front of here, and this is going to factor as that quantity of y plus 2 squared. And if I add all of this stuff up, I'm left with 100. And we are almost all set. The other thing we like with our ellipse is we like to have it set equal to 1. So my final step is going to be to divide everybody in this equation by the 100 on the right-hand side, because if I divide something by itself, it will equal 1, and that's my goal. So the last thing I'm going to do now that I have it ready to go is I'm going to just simplify these fractions. And all I do to simplify is just take the denominator and divide it by the numerator. So 100 divided by 25 would give me 4. And in my second fraction, that 100 divided by 4 would give me 25. And then obviously 100 divided by 100 equaled 1. That was my goal. So now I've taken it out of our general format, and now I see that lovely standard form. So now I can go and do everything I just did in example 1 for this ellipse, because now I can find all the key characteristics. I can find my center point at -2, -2. Oops, -2, -2, go down 2 that time. I can see my bigger denominator is at 25, and that's attached to my y coordinate. So I now know that this is elongated vertically. My major axis is going to go up and down. So I'm going to take that value from the 25 here, that's a squared, and I'm going to find its square root. And so a would be 5. And so now I know that my vertices are 5 units up and 5 units down, or I'm changing the y coordinate of my center. So I'm adding and subtracting 5 to that value. So if I do that, if I add 5, I would go up 5 units and land at -2, +3. And if I go down 5 units, I would land at -2, -7. And so those would be my vertices. Those are the endpoints of my major axis. They're a units up and a units down from my center because this was elongated vertically. I can see my b squared value would be 4. So b is 2. So the endpoints of my minor axis are 2 units away from my center. And again, because they're attached to the x, I know it's a horizontal change. I'm going to go 2 units left and 2 units right off of my center, which for my co-vertices means that I'm now changing the x coordinate of my center, but keeping the y coordinate of the center the same. So if I go 2 units to the right, that would give me -2 + 2, which would be 0, -2, which was that point I got on the right-hand side there. And if I go 2 units to the left, that would be -2 - 2, which would give me that -4, -2. And again, those are the points I need to draw my graph, and I'm just going to draw my ellipse. Again, I like to think of it as drawing rainbows. I'm going to connect these guys, making that curve, and then do the same thing upside down. All right, the other 2 things we want to find, just like we did in our first example, are our foci and our eccentricity. And so in order to get both of those values, I need to find c. So again, I'm going to use my formula, c squared equals a squared minus b squared. A squared was the 25, b squared was the 4. So c squared would be 21, which would mean c was radical 21. So my foci are radical 21 units away from my center. So I would go, again, along my major axis up and down those c units. And again, radical 21, it's about 4.6. So that means when I go to find my foci, I'm taking the y coordinate and adding or subtracting that radical 21 or that 4.6. So I'd go to -2. If I go up 4.6 units, I would land at 2.6. And if I go down 4.6 units, I would land at -6.6. And we're just going to eyeball on our graph here. And so those would be my foci. And then finally, for eccentricity, I'm going to do the ratio of c divided by a. So radical 21 divided by 5. And that was actually the same exact value we had in example 1. It worked out to be about 0.92. And again, we can see that this is a pretty elongated or stretched out ellipse. So that was all the work we had done in part 1 of our ellipses. We looked at graphing, identifying key characteristics, and drawing graphs to get them. The last thing we worked on is writing equations. And when we write equations, what's going to happen is we're going to now go backwards. And so when we write our equation, we have to know whether it's opening up horizontally or vertically so that we know where to put our a squared value. But the good news is whether they give me my co-vertices, my vertices, or my foci, My center is always going to be at the midpoint of them. So when I go and I'm given that, I'm usually given a pair of points and I'll be able to find my center right away. And that's going to give me half of what I need. So I'm going to go ahead and find my center for this first example by just finding the midpoint of my vertices. And again, the midpoint's just the average of those points, which means we're going to add our x's and divide by 2. And we're going to add our y's and divide by 2. So my center for this one's going to be at 7, -1. And the good news is that that's half of what I need to write my equation. So I'm going to go start filling in my equation here. So I have the numerators. Now all I need to know are what's a squared and b squared. Now again, a is the distance from the center to a vertex. So if I know vertex to vertex, that's the length of my major axis. And if I have covertex to covertex, that's going to help me find my minor axis. And the other nice thing is if I know where my major axis points are, then I also can figure out whether or not my a squared is going with the x's or the a squared is going with the y's. So I'm just going to do a quick sketch of my points here, and I don't even draw a full coordinate plane, I just do a rough sketch. So 7, 5 would go right 7 up 5 units, 7, -7 would go right 7 down 7 units. So my major axis right here is vertical. And if my major axis is vertical, that means now that I know it's going to go with my y's. My a squared is going to go with my y's. And again, the distance from one vertex to the other is going to be 2a. And so I'm basically going from this point up here at 7, 5 down to that point right there. So if I want to know how far apart these points are, I'm just going to subtract those values. So 5 minus -7, which is 12, would give me my length of 2a. So that means if 2a is 12, then a is 6, and now I know that I can put that 36 down there in my denominator. Similarly, my covertices, the distance between my covertices is my minor axis, which would give me 2b. And if I look at my covertices, I can see that they're moving left and right. One's over at 12, -1, and one's over at 2, -1. So if I want to know how far apart they are, I'm going to subtract the x coordinates from my covertices. And if I do that, I'm going to find my value for 2b, and 12 minus 2 would be 10. And so if 2b is 10, then b is 5, and if I square that, that's my value for b squared, and there's my equation. So when I'm given my vertices, I'm going to be able to use them to find the midpoint, and then find the distance between them to find my major axis length, and then I'll be able to find a. And if I plot them, I know my vertices are going up and down, then I know I have a vertical major axis, and I know my a value has to go under the y in my equation. If I'm given the covertices, those will give me the distance between my two covertex points, which would create my minor axis. If I find the distance between them, I would know that the distance between them is 2b, and so I can use that to find my b value. And if my covertices are horizontal, that means my major axis had to be vertical. And again, you can kind of look at what point you changed in each one to kind of know who it was connected to. So when I found my 2a value, I was subtracting the y coordinates. So it made sense that a would go up with my y values. And when I was using my b values for my covertices, or to find my b value, I subtracted the x coordinates. So it only makes sense that b is attached to the x fraction there. We're going to look at one last example where we're given our foci, and instead of given all of those points, we're actually not given any of the points that are actually on the outside edge of our ellipse. So we're going to have to do a little bit more work. But again, whether they give me major, the vertices, covertices, or foci, I'm going to always start by finding my center right at the midpoint. So I'm going to add my x's and divide by 2. I'm going to add my y's and divide by 2. And I'm going to find my center right away. And again, once I have my center, I'm about halfway done the problem. I can go ahead and fill that right into the numerators of my fraction. And all I have to do is figure out what's a squared and b squared and whether or not the a's goes with the x or the a squared goes with that y. Okay, so that's good. Now, when I get the distance from my foci, that's going to give me the value for 2c. Because again, from the center to each focus point is c units. So from one focus point to the other is 2c. So let's do a quick sketch of our two focus points. So at 1, 8 and at 1, negative 16. The distance from one point to the other is 2c. And so if I'm looking at it, I'm moving up and down from focus to focus. And again, they lie on my major axis. So if I'm moving up down from focus to focus, and it's a vertical line, that means my major axis is also vertical. So that means that when I'm looking at this, I'm adjusting the y coordinates, and my a squared value, when I find it, is going to go with my y coordinate, because a and c always move the same direction. All right, so we're going to find 2c. So to find 2c, we're going to take the distance between those two focus points. I'm using my y coordinates. So 2c is going to be 8 minus negative 16. Oops, 8 minus negative 16. So 8 plus 16 would be 24. And so c would be 12. That doesn't help me yet because neither of those need c. So I have to go and look at my second clue, and they told me the length of my minor axis was 10. So again, my minor axis length is 2b. So if my minor axis is 10, then 2b is 10, which means b is 5. And again, I know that this was a vertical major axis, so I know the a is going to go under my y. So that means that b value of 5 I just found, if I square it, that's going to go under my x. And then finally, to finish up, all I have to do is get my value for a. And what we're going to do to get that value is use, again, the relationship that we usually use to find c. We know that c squared is equal to a squared minus b squared. We've already found out c was 12, so c squared would be 144. We don't know a squared, and we know b squared is 5. B is 5, so b squared would be 25. If I put in my values for b and c into that equation, I can now solve for a squared. If I add the 25 over, I can say 169 is a squared. And that's all I need to find. I don't actually even need to find a unless I wanted to get my vertices and draw my graph. All I needed to do is write my equation, so I am done. All right, so it's always important to find your values for a, b when we're looking at that. And again, the distance from a focus point to another focus point is 2c, but it does lie on my horizontal axis, so it's going to follow the same, it lies on my major axis, so it's going to follow the same pattern as my major axis. And if I have of the two vertices, I'm going to be able to use them to find my major axis, which is my value for 2a. And if I have my covertices, I'm going to be able to find my value for 2b. All right, so that pretty much reviews everything that we've looked at so far. If you still have questions, please reach out to me and let me know.